Good morning, everyone. Thank you for joining us for this webinar on exchanging Rockwell CPU tags with the Horner OCS. Presentation itself is roughly about 17 minutes or so. And if you have any questions, you can pop them in the panel and we'll get to those at the end.
Welcome to today's tutorial. Let's get started. Let's have a look at our agenda for today. Today we're looking at exchanging Rockwell Logix CPU tags with the Horner OCS. First, we'll look at what is Logix tag exchange and who might use it. Then we'll give you the workflow showing the steps required to set it up. We'll demonstrate that using register-based advanced ladder, and then we'll show the differences if you're setting it up with variable-based advanced ladder. So what is Logix tag exchange? Logix tag exchange is a method of data communications between a Rockwell Logix PLC CPU and a Horner OCS for exchanging tag data for variables that reside within the Logix CPU. It uses Ethernet IP type messaging to accomplish that. This feature is supported by a variety of OCS models, including the Micro OCS X5, the entire RCC series except for the 6512, the XL series for the XL4 up, and the entire XL Prime series. It's not compatible with the XLE, XLT, or the Micro OCS series aside from the X5. So who might use Logix tag exchange? If you're an automation end user and you have a mixture of Rockwell equipment and you have Horner OCS equipment, then you might use this approach to exchange data between that equipment. Or if you're an OEM machine builder that happens to have both Rockwell PLCs and Horner OCS equipment, it might also be a method you could use with your system as well. In order to use this method of data communications, you have to have access to the program that's running in the Logix CPU. That's because in order to set up the communications, you need something called an L5K file. That's a file that is created from RS Logix software through a save as operation. Cscape will use this file to get all the information it needs on the tags that are available from the Logix CPU. After you have everything set up and running, you'll get update times approximately every 25 milliseconds. Now let's talk about the workflow to get everything set up. We start out in the RS Logix software where you create the L5K file. In your project in RS Logix, you save as an ADU file, but then you do a save as to create the L5K file. Then there's an optional second step within RS Logix that we recommend, and that is to perform an export function of your tags as a CSV file. That's available in the Tools section in RS Logix. Then you leave RS Logix and open Cscape. In Cscape you can import the L5K file, and as part of that process you can browse and select the tags that you want to map over into OCS register space or OCS variable space. Then as a final optional step, which is recommended, you can use a spreadsheet or text editor to take the data from within that CSV file you exported in RS Logix to help you import the variable names or IO names that you'll need to use within Cscape for the data that you're exchanging with the Rockwell CPU. Because those names don't come over to the OCS registers or the OCS variables automatically. Now we'll demonstrate this method. First, we'll show you how to set up Logix tag exchange if you're using register-based logic. Before we can import logic tags into Cscape, we need to create an L5K file from RS Logix that can be imported into Cscape. So this is the program running live in the CompactLogix controller. So I'll do a save as to create the L5K file. I'll just hit save, and now I've created that file that I will later import into Cscape. Next, I want to export my tag names into a CSV file. That can be used later to help me create IO names inside of Cscape for any tags that I choose to map into local OCS register space. Because when I take those tags and map them into local OCS register space, those local OCS registers don't by default have a name. So to create those, typically I want them to have the same name as the tag that was imported, or that they're tied to. That's why I like to use that CSV file to do that, especially if you have a lot of tags. So I'll go to the Tools section of RS Logix and hit Export. So again, when I export tags and logic comments, I'm exporting a CSV file. Now in Cscape, I'll go to the Program menu and I'll select Import Tags from L5K file. Here I'll import device, which is where we find the L5K file that we previously exported from RS Logix. The name that was captured of that CPU comes through. The IP address is set to some default, so I'll change that. In my system, that's 192.168.0.10. So this name came through, but it's actually too long for Cscape. Cscape wants a descriptive name of 12 characters or less, so I'll just change the name here, and I'll change it to Rockwell. Now we're ready to import tags. So I can expand the Rockwell controller, and we have two groups of tags, controller tags and main program tags. We can bring over just the tags that we want. For my controller tags, I want auto mode, so I'll highlight that one and add it. I also want e-stop and pump run. I'll quickly add them now. On the main program side, I want the offset point, the onset point, and the tank level. So those are the 6 tags I'm importing. These will be mapped into OCS register space in alphabetical order. I've selected R1001 as the starting point for each of these tags to be mapped, so they'll be tagged in that consecutive area of memory. Any tag that's 1 bit long will be stored in an entire register. The lower bit of the register will store any Boolean tag. Any tag that's an integer long or 16 bits long will also be stored in a single register. Any tag that is double integer or float that is 32 bits long will be stored in 2 consecutive registers. When I hit OK here, it gives me a notice that the tags are going to be mapped in alphabetical order, and not the order in which I selected them. Next, if we go back into the program, import tags area, you'll see that Cscape has put them in alphabetical order. Now we can also take a look at the scan list for the tags that we've imported. This just shows us register by register what tag on the Rockwell side has been mapped into our application. Next, I'll work on building the IO names for imported tags. I've just imported 6 tags, so I could very easily just go into the IO names editor under program and IO names and just add 6 of those in manually. But if you had hundreds of tags that you're importing, you don't want to create those all manually. We exported the tags from the Logix program in an earlier step, so that CSV file is available to us. I've opened that in Excel. So here's my spreadsheet. I have my controller tags at the top, and then I have all my main program tags down here. We did import them in alphabetical order, which will come into play later. I'll create a new sheet on this file, and I'll fill in the format that is normally used when you're importing IO names into Cscape. It starts off with the address, then the size, and then the name, which is the IO name, and then a comment, which is optional. Let's gather up the tags that we want to convert into IO names. I'll go to the top, find these 3, and then we'll also select the column that tells us about the size of these. I know that these are all 1-bit variables, but if I had many variables, I wouldn't want to have to remember the size of each of the variables. So I'll copy this and bring it over here and paste it. Then I'll gather my other 3 tags, and I'll separate them down here because they are part of my program tags. I'll copy those, and then I'll go back to my other sheet and I'll paste them. Then at the bottom I have my tank level, which I'll copy. Then again I'll go over to my other sheet and paste it. So let's put these in order. We decided to map them all starting at R1001, and remember, for every bit type or word type tag, they'll take up a full 16-bit register. Next, let's populate the 6 consecutive registers in our example here that are going to be imported. I'll make the name column a bit bigger. Remember, these are part of our program tags, so when they're imported they all have a PR prefix. So these first 2 are going first, followed by these 3. Then finally followed by this one, because again these will start with a PR as they're imported, and this one has a PU. So I'll put that here. And for a comment I'll just put imported from Rockwell. And that feature is optional. Then I'll stretch this down here for all the IO names. Now let's talk about size. These 3 are actually bit type, and these three are word type. Remember, when we imported them, they import into a full word. So for now, let's make these 16-bit in size. So we'll import them all as 16-bit variables to start. There's a bug in Cscape where it doesn't import the last one in the list. So I'll add another one to the list, and I'll just use always on, so that even when this bug is fixed, if it gets imported, it's not a problem. To actually do the import, what we do is highlight this piece of data, and then right click and copy. Then we go back into Cscape, go back to Program, IO Names, and we hit the paste button. It says, are you sure you want to paste these IO names and overwrite any duplicates? And I'll hit yes, and there they are. And finally, I need to hit OK. So let's look and double check our work. I'll go back into Program, Import Tags, and I'll click the protocol scan list and see if we got these right. This is a good way to double check our work. We can see here we have auto mode, e-stop, offset point, onset point, tank level, and pump run. So we have them in the right order. Now I'll do another step, which is I'll change the tags that were 1-bit variables to 1 bit, so that when I go to use them in my program, they're actually the right size. The ones I need to change are auto mode, e-stop, and pump run. So in Excel, I'll change each of them to 1 bit. So first I'll change auto mode to 1 bit, and then e-stop, and then finally I'll change pump run to 1 bit. Then I'll add a suffix on the end to differentiate this IO name from the one I've already imported. So next I'll highlight these again and hit copy. And I'll go back to Cscape, go back to IO names and hit paste. I'll say yes here, and now we have additional tags that are of the Boolean type. Those will be useful to us when we go in and use them in our program. Again, if we quickly go back to Program, Import Tags, and to the scan list, everything still lines up. But when we go into our program and use the tags or the imported IO names, it makes it really easy to find the ones that we want. So I can go to the View Edit Screens now and populate on these objects the tags or the IO names that I want. So for each of these bit type graphical objects, I assign them all to T1 as a temporary measure. For each of these integer type tags, when I created the screen originally, I just mapped them all to R1, since I drew my screen before filling in the proper variables. So now I just need to go in and fill in the appropriate variables for each of these objects. I'll start with e-stop, and I can just put it in right from the list. So there's e-stop boolean, so I'll select that. Next, let's go to auto mode, and again we can just find it from the list and select it. Next we'll go to pump run, and here is pump run boolean. And then these two will just have the original names because the types are matched. So this is the onset point, so I'll scroll up and select that. And then we have the offset point, so I'll go into the list and find that. And then finally we have tank level. So now we've populated on the screen here. So now we just need to download this to the OCS. Now let's look at this in the OCS. So here is our setup. We have our IO simulator where we're using the switches for simulation, and those are wired into the IO card. Then we also have an analog pot that's wired into this 8-bit analog card in the last slot. That 8-bit resolution is a low resolution, which is contributing to the bounciness you see there on our water tank display. So let's start with setting up an onset point and an offset point. So in auto mode, our pump will turn on at 100 and off at 50. And that data is being freely exchanged with the Rockwell Logix CPU along with the water tank level. To operate our system, we need to make sure our e-stop signal is okay. That's wired into the 6th switch, and you can see it turning on there. Next, we need to go into auto mode, and that's wired into the 4th switch. And since we're in auto mode, now I can dial up the tank level, which I'm simulating with my milliamp pot. And then as I go above 100, we should turn on. and as I get back below 50, we should turn off again. So you can see everything is working as it should, and we have a free exchange of tag data between the OCS and the Rockwell CPU. That's the approach if you're using register-based advanced ladder. So what if you're using variable-based instead? Next, in this short demo, I'll show you some of the differences if you're using variable-based advanced ladder and you want to import tags from a Logix CPU. So I started out in my variable-based advanced ladder by creating an array variable. So it's an integer type array, and I sized that at 500, which is a size you may use if you had a large number of tags that you want to import. Obviously in my demo here, I have 6 tags that I'm importing, so I don't need that size, but it's the size you might use for a larger project. Then I map this array starting at R1001. When you're dealing with communications, it's usually best to map your variables, and that can be easily done in the program variable editor. Next, let's head to program, import tags from L5K file, and we're going to follow similar steps as before. We import device, find our L5K file, set up our IP address, and once again, this name is too long for Cscape, so we'll call it something shorter that's within 12 characters. I'm not going to change the port number. And there we are, and we'll import the same tags as we did before. And I'll do that quickly now. Of course, in here, we need to put a variable and not a register. So we'll select the first element in the array that we previously created. And that's the main difference when it comes to importing tags. You're just selecting the first member of an array instead of a specific memory location. So just like in the register-based advanced ladder, I added in names for all the variables that I imported locally for Cscape. I put them in retained variables. So there's my original array, and then there's all the individual variables in the proper order, and they're all mapped to the proper location. You don't have to manually enter them from here. You can take advantage of the edit variables as text feature and use one of the available formats in your text editor, whether it's IEC format, XML, or CSV, to import using your text editor instead of just manually typing them in. So that concludes our demonstration for today. Thank you for joining me for today's tutorial, and the Q&A session will begin shortly.
Okay, I'm not seeing anything in just yet. Just a reminder, I know we have it on the website, which I should actually show you now. Just a reminder, we are in SPS next week in Nuremberg, so there will be no webinar next Thursday, but we'll be back the following week with a more stripped back installing your OCS webinar. On that, thank you all for joining us, and we hope to see you again.